Welcome to ClickMyProject.com. Our project title is the Unpaired Image Captioning by the Image Level Weakly Supervised Visual Concept Recognition Content. This is an abstract. Goal of our process is to determine the image without the caption phase in the training phase. Unpaired image captioning aims to caption pictures without requiring pairing of images and captions during training. Although difficulty, we anticipate that the task may be completed by recognizing a training set of pictures that are in the line of with the visual notations. Due to the high cost of the relation-triplets labels or bounding box labels used in the training, the majority of research employ of the self-techniques to generate the visual ideas. We provide a unique method to produce a cost-effective UIC in order to address the issue with the pricey annotations. In particular, we use the image level label for the weekly and supervised UIC model optimization. We assume that for each image, just the image level labels devoid of precise coordinates and numbers are given, such as item name, item types, and relationships. In our process, we use a deep learning model like CNN LSTM for the large number of datasets and generate the image captioning as from the image dataset. This is our objectives. Image captioning technique without a caption in the image. Improve the accuracy. Deep learning algorithms is mainly used for the image captioning and improve the performance analysis. The system architecture. From the image dataset, we want to select the image and pre-process the image dataset and split the data and extract the features and classification using the deep learning algorithms like CNN and LSTM and prediction. Finally, predict the caption for the correct image and performance analysis. We have to calculate the accuracies and loss. This is a flow diagram. We want to select the data from our data set and then pre-process it by the label encoding and remove null values and the data splitting. We want to split the data sets at training and testing and extract the features and classification, CNN and LSTM and prediction, performance analysis. Finally, we get the loss and accuracy of the image and get the predicted caption for the image. This is a use case diagram from the user point of view. First one is the data selection, next one is the pre-processing, third one is the data splitting, and fourth one is the feature selection, and then classification, performance analysis. Here architecture. From the start, we want to load the data set and pre-process it and split the data and extract the features according to our need, and classification using the deep learning algorithms. Performance analysis. Here we define the predicted label for the image. Sequence diagram. We have four types of sequence. First one is the starting, second one is the pre-processing, and third one is the classification, performance. Select the start, select data set and load it, and pre-processing we want to split the data. Classification we want to apply the deep learning algorithms like CNN and LSTM, and performance analysis find the predicted caption for the images. After executing our process, our app looks like this. This is an image caption generator. We want to select the image by using the browse files. This is our image dataset. We want to select one image. This is our generated caption. One second.